Hey guys, thought I'd walk you through a few more examples of the quadratic formula. For this first example, we have 2x squared plus 7x equals 9. Our first step, as always, is to determine our a, b, and c. So our a there would be a positive 2. Our b would be a positive 7. And remember, it's always the sign that comes before the term that tells us if it's positive or negative. And our last term would be c, and that would be a negative 9. So I know a equals 2, b equals 7, and c equals a negative, I said it but I didn't write it, a negative 9. Alright, so now we need to plug it into our formula, which is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So b is 7, so the opposite of 7 being negative 7 plus or minus the square root of b squared minus 4ac all over, don't want that, all over 2a, and our a is actually our 2 as well, so 2 times 2. Our next step would be to simplify our radical, so that's the same as negative 7 plus or minus the square root. And if I go back up here, 7 squared would be 49, so it would be 49. And then I have a negative 4 times a 2 times a negative 9. Well, negative 4 times 2 would be negative 8, and negative 8 times negative 9 would be a positive 72. And that'd be all over, well, 2 times 2 would be 4. And that would be the same as negative 7 plus or minus the square root of 49 plus 72 would be 121 all over 4. And this is the part where I guess I realized since I could get the square root of this first, so this would be the same as negative 7 plus or minus the square root of 121 is 11 all over 4. So that's leaving me with 2 different problems to solve. I'm going to have to now solve, I'm going to have to solve, okay, what happens when I have negative 7 plus 11 over 4? Well, that's the same as 4 over 4, which equals 1. So that's one of my answers, a positive 1. And what happens when negative 7 minus 11 over 4? And that's the same as negative 18 over 4, which equals a negative 0.25. Once again, you can use a calculator on this, please do. But that is an example of a 2 solution. Once again, we know this had 2 solutions because under our square root sign, our discriminant, it was positive after we simplified it, and that tells us it will have 2 solutions. After we get down to one number inside the square root, if it is positive, we'll have 2 solutions. If it is 0, we will have 1 solution. And if it's negative, we will have no solutions. All right, let's look at this next example. We have 4m squared equals 7m plus 2. We have a little bit of a problem with this one because it's not set equal to 0. And if I zoom back out again, the quadratic formula works when we have ax squared plus bx plus c equals 0. We don't have that. So if I look here, my first step is to get all of that on one side of the equation. And by one side, yeah, so I would subtract 7m, and I would subtract 2, I would subtract 7m, I would subtract 2. Those would cancel out, and that would leave me with 4m squared minus 7m minus 2 equals 0. And I did that to get in standard form of ax squared plus bx plus c. Once I did that, I know that my a is going to be equal to, I'll highlight all those at once. A is going to be equal to 4, b is going to be equal to negative 7, and c is going to be equal to negative 2. So when I plug that in the quadratic formula is the opposite of b. So if b is -7, it is now +7, plus or minus the square root of b squared, so -7 squared, minus 4 times my a, which is 4, times my c, which is -2, all over 2 times my a, which is 4. I would then have to work on simplifying my radical. So I would have, I'm going to draw a line here just so you guys can see what I'm doing. I'd have, sorry, 7 plus or minus the square root. -7 squared would be 49. And I'd have that, then -4 times -2. Well, -4 times 4 would be -16, and -16 times -2 would be a positive 32. All over 8, because 2 times 4 is 8. That would then simplify down to 7 plus or minus the square root of 70, 81, all over 8, which is the same as 7 plus or minus 9, all over 8. So now let's have to break up into two parts. I have to say, okay, what happens when I have 7 plus 9 over 8? And what happens when I have 7 minus 9 over 8? Well, up top, that'd be the same as 16 over 8, which equals 2, and 7 minus 9 over 8 would equal a 0.25. And now that I did that, I think I told you guys wrong earlier, and I sure did. I'm an idiot. Sorry, -18 over 4 is not 0.25. It is not. It would actually be -4.5. Sorry, looking over for an answer key as I do this. Looked at the wrong answer for the wrong problem. So I apologize for that right there. There is the answer to that one. Okay, for the last one, once again, we don't have it in ax plus bx, ax squared plus bx plus c form, so I need to get it that way. So I need to subtract w and subtract 6, and subtract w and subtract 6. Those would cancel out, and that would leave me with 5w squared minus w minus 2 equals 0. I would then have to find my a, b, and c's. My a would equal 5, my b would equal -1, and my c would equal -2. Quadratic formula says opposite of b, so if b is -1, I'd have positive 1, plus or minus the square root of b squared minus 4 times my a, which is 5, times my c, which is -2, all over 2 times my a. My a, once again, is 5. I would then need to simplify what's in my radical. 1 squared would be 1, so I'd have, I wanted that. I'd have 1 plus or minus the square root of 1. And -4 times 5 would be -20. -20 times -2 would be a positive 40. And 2 times 5 is 10. So that would be the same as positive 1 plus or minus the square root of 41 all over 10. So I can't take the square root of 41 without using a calculator because it's not a perfect square, so this is where you would bust the calculator out, and you have to do two separate problems. You'd have to do, hey, what happens when I have 1 plus the square root of 41 over 10? And what happens when I have 1 minus the square root of 41 all over 10? And I have my calculator out here. I'm not going to split screen this time. Also, you guys know that this one's approximately 0.74 or 74 hundredths. and this one is around 0.5454, and that's negative hundredths. So I'll post these to